All right, let's jump right in and solve one of those classic math mysteries that probably bugged you at some point. Why in the world isn't the number 1 a prime number? You know the list, right? 2, 3, 5, 7, 11. Those are the primes. But what about 1? It's the most basic number there is, but it's never on the list. Kind of feels like it got snubbed, doesn't it? So yeah, it's this weird little situation, kind of like a paradox. On one hand, it feels like Puronic fits the bill, but it's kicked out for a really, really important reason. And trust me, by the end of this, it's all going to make perfect sense. Okay, so let's look at the official textbook definition. Most of us remember the part about a prime being divisible by 1 and itself. But check out the fine print. It says a whole number greater than 1 that has exactly 2 distinct divisors. And those little details, well, that's where the trouble starts for our number 1. And you can see it right here. A prime number, like 2, has 2 divisors, right? 1 and 2. Same for 3, 1 and 3. But look at 1. It only has 1 divisor, itself. So, case closed? By the technical definition, yeah, it's out. But that's just the surface-level answer. The real reason, it's so much cooler and goes way deeper into how math itself is built. To really get it, we need to think about what prime numbers do. They're not just some random numbers on a list. They are, quite literally, math's building blocks. Seriously, think of them like atoms or Legos. Every single whole number that isn't a prime itself is built by multiplying prime numbers together. They're the fundamental, indivisible pieces that construct everything else. They're the absolute foundation of arithmetic. And this leads us to what is maybe the most important rule in this whole discussion. It's called the fundamental theorem of arithmetic, and it basically says this. Every number has its own unique set of prime factors. The keyword there is unique. It's like a fingerprint or a recipe that belongs to that number and that number alone. Take a look at this. The number 6. Its unique prime recipe is always 2 times 3. That's it. No other primes will make 6. What about 12? It's always 2 2s and a 3. Or 30. It's always 2 times 3 times 5. It's this beautiful, clean, predictable system, and that's what makes math so powerful and reliable. But this whole beautiful, elegant system, it hinges on one thing, keeping the number 1 out of the prime club. So now, let's break the rules. Let's see what happens when we invite 1 to the party. Welcome to the chaos of 1. So what if we just did it? Let's just pretend for a second that 1 is a prime number. We just let it join the club. What's the worst that could happen? Okay, let's go back to our friend, the number 6. We know its unique recipe is 2 times 3. But if 1 is prime now, we could also say 6 is 1 times 2 times 3. That's true. But wait, what about 1 times 1 times 2 times 3? That also works. Or how about we just throw in a billion ones? You see the problem? We could do this forever, and the answer would always be 6. And just like that, the idea of a unique recipe is completely gone. It's shattered. The number 6 doesn't have 1 prime fingerprint anymore. It has an infinite number of them. That core rule, the fundamental theorem of arithmetic, is broken. And when that rule breaks, everything gets messy. The entire neat and tidy structure of numbers falls apart. So you see, excluding 1 isn't some arbitrary decision. It's not about being picky. It's a crucial move to protect the very order and predictability that makes math work in the first place. So if 1 isn't prime, then what is it? Is it just nothing? Nope, not at all. It's so special it gets its very own classification. In the world of mathematics, 1 is called a unit. It's in a class of its own. It's the multiplicative identity, which is a fancy way of saying anything you multiply it by stays the same. And giving it this special job as a unit is exactly what allows the world of prime numbers to stay so perfectly organized. Okay, so let's tie this all together. The short answer is that the 2 divisor rule technically kicks out 1, but the real reason, the much deeper reason, is to protect that unique building block system. By setting 1 aside as its own special thing, a unit, we ensure that the rest of math stays clean, orderly, and predictable. So the next time you see that list of prime numbers, you'll know that 1 isn't missing because it's unimportant. It's missing because it's too fundamental. Its job is different. And it really makes you think, doesn't it? What other simple, seemingly small rules are out there, quietly holding the entire universe of math together?